It's like when I do both of these, it's almost like I combine both. Like, I get confused.
Combine both of what?
The steps,
Oh,
and then I don't know. I always end up.
Well, maybe practice some more, maybe more problem will help.
Yeah,
That'll be some steps. Just get the steps down.
Are we recording?
We are recording.
Can Amber hear?
Hey, Amber.
I can't hear you.
This the concepts. I don't know the one that
This is that method of factoring we did last class. Okay, we're just reviewing that one more time. This is number two from your homework on AC method from last class on Thursday. Is that okay or no? Oh, I usually turn off at least one. It depends on if the smart board is on. And we got it. It's nice outside today. Okay, for this technique, what's the first step? Who can remind me? Marcus?
You find the A and the C.
Good. So find AC and find B.
AC will be 5, 2, 3, a 100,
And then just 2.
100.
12.
You're good.
12.
No, 10.
You had it right. Again, you did 80 plus 32, right? That's what we were doing ahead. Very good. Again, 8 times 14, think of it as 8 times 10 and 8 times 4. And then B is negative 24. So this is a tough one, right guys? Because the factors of 112 are difficult to list. They're not easy. They're not apparent. They don't show up right away. So we have to sit here and go through them. Now, there are ways to make it easier on us. Let's figure that out. So first, if I want to list the factors, I could always start with 1 and that number. But right away, if I put a 1 and a 112, is that going to add up to 24 or negative 24? No, it's not. So I really don't even have to list these. I will, but I don't have to. Those are my first two factors. Then what do I try next?
22. I'm talking about 112.
For 112, what's the next smallest number, next biggest number after 2? Well, after 1. 2. Sorry, I gave that away. So try 2 next.
Good job.
Hey, 2 goes into 112 for sure, right? 56. Now, 2 and 56 don't give me 24 still. No combination of that works. So right away we know those are not working. Mia, did you figure one out? What do you got for the next one? What do you think? 4, okay, I'm going to leave it blank because I know 3 is going to work also. So what was 4? 4 and? Good, negative 28. So how did you not figure it out? I think you got it right here. Because look, negative 28 and 4, that's your number right there. Add those up, you're going to get the value of B, Ebony. Remember, we're adding them up to get B. That's the whole technique here. Do we even have to list the 3s?
No.
It doesn't matter, right? You want to do it?
No.
No.
That's like a waste. When you over-explain things, I don't get it.
Again, these are not needed. These are not needed because we got the answer, so we don't care about those anymore. Again, why our answer is what it is. 4 and negative 28 gives me negative 24. So when you add up these two numbers, you get this value. Again, the whole idea is to add up the factors to give you B and to multiply to give you AC. So now I break this one up. I write it again as oh no.
No.
Okay, better. So again, where did I get these numbers? This value and this value comes from this right here. Again, in the red box over here, you got a million colors going on. In the red box, these two values are what come up here. Red box.
Red box.
Wait, so those are the factors of 112?
4 and 28, 4 and negative 28, and factors of negative 112 that also add up to negative 24. These are all factors of negative 112. This is the only one that adds up to give you this.
So all we basically gotta do is find out what equals B.
What multiplies AC and adds up to B. At this point, then we use that grouping technique, where we look at this and we say, let's split it down the middle.
Oh, yeah.
Okay, we look at the first two terms. What can I factor out of 8 and 4?
4.
4 what else? What's up? What else is in both?
4x.
4x is both. Good. And again, make sure you write the right factor here. How did we do this last time? How did we get the 2x plus 1? Was that?
For this, do we take away the 4 outside of the parentheses as well as the 8, I mean the 28?
Over here?
Yeah.
You're going to factor out a 4 for sure, right? You said? This 4 goes into 28, but does 4 go into 14? It doesn't. So you're going to have to call it something else there. We'll get to that in a second. Let's go back to this for a second and ask the question. How did I know 2x plus 1 is what remains here? How do I know 2x plus 1 is what remains?
Because that 8. Oh.
I showed you guys a little trick last time.
Stop. Distributed.
Okay, it's the undistributive, so you can redistribute. But if you didn't know that, some students get a little frazzled. Divide by whatever you factor out. Divide by whatever you factor out. 4x over 4x gave you the 1 here. 8x squared over 4x gives you the 2x. So whatever you factor out, you can actually divide these in your mind, and that's what's left over. Again, you divide these and you get this one. If you divide these two, you get that value right there. This here, it's the greatest common factor, the GCF. What is the GCF on the right-hand side? What can come out of both of these? 7, right? But if I only take out a 7, if I take out positive 7, I'd be left with negative 4x minus 2. Is that going to work? It's not going to work, right?
No.
What do I have to take out here? There's something bigger than 7, guys. What is it?
14.
14. 14 goes into both these, doesn't it? Use 14. It's the greatest common factor, not just a common factor. That's a tricky one. So here now, if I take out 14, I'm left with a 2x and then a 1 here. But the problem is that I need these both to be positive, don't I? Isn't this 2x plus 1? So this has to be 2x plus 1. They have to be the same. They have got to be the same. So if this is 2x plus 1, this needs to be negative 14. Once again, to get a 2x plus 1 over here, and I'll rewrite that so it looks clearer. To get a 2x plus 1, you have to take out a negative 14. So whatever you get over here, you can already take this value and put it in over here. Once you know what that is, you can then figure out what the factor is you have to take out. So the second part, you don't even have to think about GCF. Just list the same factor and take out whatever needs to come out to get that factor. How do you get this? Well, take out a negative 14. Divide by negative 14. Divide by negative 14. You get those values. Now at the last step, what do I do? Because I'm not done. I need to write, I only have 2 factors in the end, and I see a lot of stuff here. What should my final answer look like? Pardon?
Isn't it 4x minus 14 and 2x plus 14?
Awesome job. Again, she takes the coefficients on both sides, the 4x, the minus 14, that goes over here, and then she repeats one of these 2 factors over here. Again, this technique is difficult, but if you want to sit here all day and try and guess these values from the original, go ahead. Chances are it's going to take you like 30 minutes to guess all that. Because look at all these possible factors you could have had.
Man, I guess we should have to take 30 minutes.
Do the technique more and more, and it'll make it a lot easier for you guys. Again, I'll give you a handout tomorrow, but this is going to say the same thing that the handout says.
How'd you get this?
How do we get the plus sign?
Yeah.
We have positive 4 and negative 28. So we took this middle term here and broke it into positive 4 and negative 28. Like these 2 here come from these 2 here always.
Okay. Yeah, I get that.
So if you want to draw an arrow, you know? that goes to these two values. Okay? Oh, and you had a hand up.
Yes. What you try to find the greatest common factor in AC or B?
Once we get to here,
Yeah.
we find the greatest common factor of the left part of the equation, the greatest common factor of the right part of the equation. We're finding the GCF of these two, we group these two together, and then we group these two together. It's called grouping technique.
What
Read through it, you remember that?
don't you find the greatest common factor of B? See that?
Of these two, you find the GCF, and that's 4x. The GCF of these two is negative 14.
Okay, so what step do you do after you find out AC and B? After that, what do you do?
Once you get this, and you got this whole lineup up here,
Yeah.
then you start factoring. You factor the GCF here, you factor the GCF over here. Once you factor the GCFs, you get to the answer. So there's only two steps here. But from here to here is actually probably one of the more difficult parts. Okay? There was another hand up somewhere. So, Bridget. Not right now. If you want more help, you can come after school. Because we have 15 minutes left to the main start the lesson. Okay? So after school, that's fine, guys. Say again?
Where's the restroom?
Concept 8, you should know the title already. We're adding and subtracting imaginary numbers, and we're looking at powers of I. And powers of I. If you were asked to add these expressions together, all you need to do is treat I like a variable. So just combine your like terms. So imagine it was a variable. What do you got? Good. Minus 3. You could have said plus negative if you thought you were going with there.
That's what I was about to say.
So all you have to do is treat them like they are variables. Again, combine like terms. So if you're writing notes down in words, because I don't write these words down, you should be writing the following. Treat like a variable. When adding and subtracting imaginary numbers, treat like a variable. One more time. When adding and subtracting imaginary numbers, treat like a variable.
One is, when we write I, is it important that we use
The bottom of
Just
it,
write a regular.
you can put a regular one, but it's been standard to have it italicized, and that's what I'm trying to show. It's
Is
italicized.
it better to write it like that?
Yeah.
Probably because if in case I don't see the dot and I look at one,
Okay.
so it just helps.
Oh, yeah.
So I would say yes. Now the other thing is this: when we talk later, we're going to talk about what's called standard form, and this is A plus BI form. And what this means is that we always want the real value here and the imaginary value here. So here we really have negative 3 plus 5i as our final answer here. Even though those are the same things, we want to have our real number over here and our imaginary value over here. Again, we have our final answer, and I'm just switching the order so that the real number is on the left. So this is the real component. This part is the imaginary component.
What is that called when you do that to them? When you put the,
When I went from here to here,
hold on, wait, I know what it's called, I just don't know what it's called right now.
it's called a commutative property.
What is that called?
It means that you can switch the order of what you're adding in.
Like from least to greatest?
That's coincidence. It has nothing to do with least and greatest. Yeah. It just has to do with real number on this side, imaginary on this side. That's real. This could have been like negative 20. It would make no difference, okay?
So I is always to the right?
So I is always on the right. Again, I is always on the right. If you were asked to say, and there's a reason I'm going through this, and I'm really going to talk about it more tomorrow, but I can give you a preview. If you were asked to say what was A is just negative 3 now, and B is just 5. Again, A is this value over here. B is whatever the coefficient of I is. So B in this case is 5. This is not A, B, and C like quadratics, where you have ax squared plus bx plus c. It's not like what we just did with factoring. A and B here are used in engineering applications, actually. This is one thing that you'll see a lot if you ever study engineering, especially electrical engineering. When you look at circuitry, you use a lot of things with imaginary numbers. And based on the value of A and B, your circuit changes. And it's actually a really cool topic. In addition to that, there's something called system controls or system dynamics. Have you ever been on an airplane before and the airplane shakes a little bit?
Yeah.
How come the airplane just doesn't like turn over, you know? Like, there are so many things that are going on. The whole airplane has this controlled feedback loop. So what it means is, if the airplane feels a gust of wind, it adjusts the flap on this side to level it back out. If, for example, the airplane is flying and it starts raining, and that affects the thrust on the actual engines, it will thrust the engines more so that it comes back to it. So it's constantly noticing any perturbations or changes in the flight, and then it reacts to that. And this is called a loop or a feedback mechanism. This is used, all imaginary stuff, feedback loops are all imaginary numbers. So if you go on to study engineering, you're going to use this. And the value of A and the value of B have huge implications on your answer. If you can somehow alter your technique to change A a certain amount, you get a totally different answer. You can have what's called an unstable system versus a stable system. And again, these are things that if you study engineering, you will see them. So I'm trying to give you a preview of why we're actually doing this. Okay, again, if you don't go on to use it, it's not a big deal. You might not use this stuff. But it is good to know the techniques for now that we're going to go through. So simply speaking, when we add and subtract imaginary numbers, you just combine like terms. Okay? Just combine your like terms, put it in your standard form. Now, there's another word for this. There's another word for imaginary numbers, and it's called complex numbers. And it means the same thing. Again, if we call this imaginary, the whole thing is a complex number. Okay, this whole entire thing is called complex. Whenever there's an I in it, they call it complex. It's just like another synonym. Just like you guys have heard of reciprocal and inverse. When you're talking about fractions, a reciprocal and an inverse are the same thing. It just means flip them over. Complex and imaginary are really the same thing here. Let's do another example. If we have 3 plus 2i minus negative I plus 4. Try it on your own, but I recommend you be careful. Don't automatically try and combine right away. Look at what's set up. Look at the way it's set up. Can somebody point out what they noticed that they had to maybe switch or notice right away? Ebony. Good. We see a negative I. Very good. It's no longer positive I, and we're subtracting. What else? There's one other thing.
Once you turn the negative I, the minus sign to plus in a way.
Because you're minusing a negative, plus. Very good. That's similar to what she said. There's one other thing, though.
The first part of the name is in regular form, and the other one is back.
Notice the I appears as the second part here and as the first part here. So just be careful. Don't combine your 2i and the 4. That's the common mistake here. Students will try and combine this value and this value. Okay, we're not, these two values here do not line up. So what we're doing is we're doing 3 minus 4, which is negative 1. Again, you are doing 3 minus 4, also known as plus negative 4 from earlier this year. Next, you are doing 2i minus negative I. What is minus a negative, Enrique? Positive. So we got a positive 3i. Again, because it's 2i minus another negative I.
Oh, that
Minus
3
a
is negative?
Say again?
Which one is negative? 3 or 4?
This is 3 minus 4, giving you a negative 1.
It's subtraction sign.
Yeah, it's subtracting a negative. Yep. Okay, that's pretty much it for adding and subtracting. Now we gotta get to powers of I. It's a joke, Melody?
You see it, right? I'm just making sure.
Now this is gonna be a little tough. I'm gonna tell you this right now. This is one of the more difficult things that students have trouble with. So please, please make sure you're focusing. If you remember, does anybody remember what I was actually used for, what it was defined as?
Imaginary.
Imaginary, good.
Irrational.
Okay, it has to do with the radical
Negative radical.
of negative.
Square
What is
root
it?
of a negative square root.
Okay, negative square root, but what was the actual number of here? 1.
Oh, yeah.
I was defined as the square root of negative 1. We did this in concept 1, actually. The first concept. Now, with that said, if I asked you to tell me what I squared was, if I square the left side to get I squared, right? To go from here to here, I'm squaring the left-hand side. So what do I have to do on the right-hand side? So this is really radical negative 1 squared. But what's a radical and a square do to each other? They cancel. So I squared is really just negative 1 now. Again, if you square the left side, you've got to square the right side. Well, if you have a square root of a square, they cancel. You're left with I squared is negative 1. So far we know these two things. I is the square root of negative 1. I squared is negative 1. What if I asked you what I to the 0 was?
0.
Careful.
It wouldn't be.
Negative I.
You can't. It can't happen. Inconclusive.
Isn't it point I or something like that?
Infinity, right?
It's 1.
It's 1. Let's go over where this comes from.
Great guess.
Now, Claude was like, if we have, and here's a quick scenario to show you where this comes from. First of all, 10 to the second power. What is that?
20.
Be careful.
100.
100. 10 times 10.
Close enough.
10 to the third power. What is that?
10 to
10
the
times
third.
10 times 10.
300. It's now.
What is it?
1,000.
1,000. What's 10 to the first power, though?
10.
Okay. Look at the exponent. See the 3, 2, 1?
Oh, you gotta add a 0.
There's 3 zeros there, aren't there? There's 2 zeros. There's 1 0. So 10 to the 0, are there going to be any zeros? So this is just 1.
You got it.
This exponent here, and this only works with 10, by the way. I can show you another way with other numbers, but this with the exponent numbers only works with 10. This indicates for 10s the number of zeros. Well, if there's no zeros, 10 just becomes a 1. So anything, so we can write a general rule, anything to the 0 power is 1. And you learned that in Algebra 1, actually. So that's a review. So this applies to the same rule. Again, anything to the 0 is 1. So far we've done I squared, I to the 0. Again, we've done I squared, I to the 0.
Just when you say to the 0, it just doesn't sound.
There's no other way to say it.
It sounds like it's not even supposed to.
Oh, to the future. Pro.
I 0? No, that makes sense. Yeah. Okay, now, I'm going to go to the next page because we're in another room. Let's list these 3. So we know that I is just I, or I to the 1 is just I. I squared we said was negative 1. We said I to the 0 was 1. Those are the 3 things that we listed so far. Again, any number to the 0 is 1. Any number to the 1 is itself. I squared we said was negative 1. Now, I want to know what I to the third is as my next question. And if you want to answer right away, you can, but it's an easy way to break this down. Try and break up I to the third into 2 smaller i's. Like if you had x to the third, you could break it into x to some other power and x to some other power. Try and break that down into 2 different I powers. What is it? Good. So I to the third is really I to the second times I to the first. Because we learned in Algebra 1 that when you multiply 2 things with the same base, you add the exponents. So 2 and 1 really is 3. Now, but I squared was defined as what? Look above. What's I squared? Negative 1. What's I to the 1? So it's just going to be negative I. Again, what we're doing here is showing that I to the third is really I squared times I. But I squared is defined as negative 1. I to the 1 is still I. A negative times a positive is just a negative.
So, why would we just write negative I?
That's what we're going to do right now. So right now what we're going to do is the following. Make a little wheel. Start up here at I to the 0, I to the 1, I to the second, and I to the third. And draw yourself little arrows to show the rotation.
Dude, very crafty.
This one here, I to the 0, we said this is just 1. This is just I. This is just -1. And now this we just said is -I. Again, the green is what they actually are, okay? The green here is what they're actually equal to. Okay? So again, I to the 0 is really 1. I to the 1 is really I squared is really -1. I to the third is really -I. What if we tried something like I to the 4th?
It'll be -1.
Be careful. If we tried I to the 4th, break it into the two things you want to break it up to.
I
Jordan.
thought it was negative.
Oh, -4. Alright, 4.
It would be negative, 1 and -3. I mean, I to the 1 pound.
Okay, and I to the... Okay, you can do that. What else can you do?
I swear.
Or I squared times I squared.
Let's do that one because it's easier. So look at I to the 4th. If you break up I to the 4th into I squared times I squared is -1. So this is really -1 times -1. Well, what's negative times a negative? So I to the 4th is really +1. So that means that I to the 4th is really the same thing as I to the 0. Because we just said that I to the 4th is really 1, but 1 was up here. So if we have 0 and 4 in the same spot, what can you predict about what else is going to happen?
And I to the 5th,
Where is that going to go, Jordan? Where is it on?
right there, next.
On the second one. Where's I to the 6th going to go?
Square.
Where's I to the 7th going to go? I to the 8th, I to the 9th, etc., etc., etc. And that's why we form a wheel from this. And what we can see is that every one of these values will end up sitting in one of these locations. We just need to figure out which location is it sitting in. So if you were asked like I to the 12th, you could say, okay, let me count. This was 9, 10, 11, 12. So I to the 12th sits up here, and that value would just be 1. If you were asked instead of 12, you were asked I to the 15th. Well, we just said this was 12. 13, 14, 15. So I to the 15th is over here, so I to the 15th is just -I. Now, do you want to count every time around? You don't want to sit there. What if I said, what's I to the 75th power? You don't want to loop, a ton of times and get to that value. So let's talk about how we can figure that out. Well, you know what? Let me leave that for you only because the bell's going to ring in a minute. So you can work on this one tonight. Okay, your homework is a worksheet. I want you to complete the worksheet as best as you can. The stuff with the eyes, leave blank for tonight. I'll give you the worksheet on the way out.
Isn't it like you want to have a 4 or something?
And look at the yes, very good. Now, here, you got to divide them again, homework tonight. Only do problems 1 through 5 on this worksheet, please.
Oh, my bad. My bad, man.
Only do 1 through 5. Only do 1 through 5. Thank you.
My bird. Look at my bird. Like, enjoy that.